key point 2. Key point 2. Perfect square always will have digital sum 1, 4, 7 or 9. Then we will see. Key point 2. Key point 2. First we will understand, then we will write down the key point. Now see here. Suppose if I take the digital sum of a number, these 1, these 2, these 3, 4, 5, 6, 7, 8, 9. If I cube it, 1 cube is 1, 2 cube is 8, 3 cube is 27, 2 plus 7 it is 9. 4 cube is 64, which is 1. 5 cube is 125. 1 plus 2 plus 5, 8. 6 cube is 216, which is 9. 7 cube is 343, which is 1. 8 cube is 512, which is 8. 9 cube is 729, which is 9. Very, very important key point. Same like perfect square. Every perfect cube, key point 2, every perfect cube has a digital sum. Every perfect cube has a digital sum 1, 8 or 9. But all the numbers with digital sum, all the numbers with digital sum 1, 8 or 9 may or may not be perfect cubes. Please write down. May or may not be perfect cubes. May or may not be perfect cubes. Very important learning. If a number is a perfect cube, it will have digital sum 1, 8 or 9. But if the number has got digital sum 1, 8 or 9, it may or may not be perfect cubes. Idea clear? Every perfect cube has a digital sum 1, 8 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect square has a digital sum 1, 4, 7 or 9. Every perfect cube has a digital sum 1, 8 or 9. One example. Same idea, sir. Idea remains the same. Structure remains the same. Every perfect cube. Now, example is 1, 5, 3, 4. Is 1, 5, 3, 4 a perfect cube or not? Is 1, 5, 3, 4 a perfect cube or not? 7, 12, 13. Digital sum is 3. A perfect cube has a digital sum, right? 1, 8 or 9. 1, 8 or 9 is 333, 999, 4 2s 1, 92, 92. Is it a perfect cube or not? These same somewhere in some examination, sir. Is it a perfect cube or not? Out, 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 out. 2. So the digital sum is 2. For it to become a perfect cube, it should have digital sum 1, 8 or 9. 1, 8 or 9. I hope the idea is clear. Perfect square over perfect cube over. Key point number 3. Please write down. Key point number 3. X cube 50 plus x whole cube. X cube 50 plus x whole cube has the same last 2 digits. Has the same last 2 digits only if x is even. Please write down. Very, very important key point. X cube 50 plus x whole cube has the same last 2 digits only if x is even. Please make a note of this important key point. X cube 50 plus x whole cube has the same last 2 digits only if x is even. In the form of square we did x square 50 minus x whole square, 50 plus x whole square, 100 minus x whole square, 100 plus x whole square has same last two digits. There is no restriction on x, but here there is a restriction. Why? Proof. 123. If I take an example 123, reminder, when you divide a number by 100, 100 ones are 100, remainder is 23. These are nothing but the last two digits of a number. These are nothing but the last two digits of a number. Last two digits of 123 is 23, which is nothing but the remainder when you divide a number by 100. 100 ones are 100, remainder is 23. So 50 plus x whole cube, a plus b whole cube, a cube, 3a square b, 3ab square, ab square, and next is b cube. Now if you observe 50 cube is nothing but divisible by 100. 50 square divisible by 100. X is an even number. Even number is 2k. 3 into 5, 50 into 2k whole square. 4 into 50 divisible by 100. What is left? X cube. Very, very important point. X cube 50 plus x whole cube has the same last two digits only if x is even. Only if x is even. X cube 50 plus x cube has same last two digits. It will have same last two digits only if x is even. I hope the proof is clear. 50 cube is divisible by 100. This is divisible by 100. Even square into 50 divisible by 100. This is becoming divisible by 100 only if x is even. I hope it is clear. That is the reason finally I wrote a point. X cube 50 plus x whole cube has same last two digits only if x is even. Example. Example. How many two-digit numbers? How many two-digit numbers on cubing ends with 28? How many two-digit numbers on cubing ends with 28? How many two-digit numbers on cubing ends with 28? There is a number, it seems, x on cubing. It will end with 28. It will end with 28. X cube is ending with 28. So x values can be 2 cube is 8, but I want 28. Next number is 12 cube is 1728. Yes, the last two digits is 28. What is the logic we discussed? X cube and 50 plus x whole cube. Last two digits will be same. Last two digits will be same only if x is even. Only if x is even. Only if x is even. So these are nothing but 12 is even. So what are the two numbers? 12 cube and next number is 62 cube. Idea clear? How many two-digit number on cubing ends with 28? It is ending with 8. If it is ending with 8, x has to be 2 because we discussed a logic. A perfect square never ends with 2, 3, 7 or 8. On cube, it will come from 2, 3, 7 or 8 from bottom to top. I hope in session number 2 we discussed this. So for it to become 8, x has to take 2. Lowest number is 2 cube 8. Next number is 12 cube, which is 1728. Which is 1728. I got 28 at the end. So number will be 12. Next number will be 50 plus 12, which is 62 cube. You don't need to do it. These both the numbers, even if you use by using a plus b whole cube, last two digits will be same. In case if you want to cross check it, 3 into a into b square and b cube, these 8. 3 6 are 18, 8. 8 into 4, 32. So 32 is 2. I hope it is clear. What is this one? This is nothing but 3ab square and b cube. Last two terms only we require, right? 3ab square and b cube. Idea is clear? One more question. Please write down, sir. One more question. Very easy once you understand the concept. But you should know all this. If you don't know only, you will get into a problem. X cube 50 plus x whole cube. Last two digits will be same only if x is even. Next one. How many 3-digit numbers? How many 3-digit numbers on cubing ends with 44? How many 3-digit numbers on cubing ends with 44? How many 3-digit numbers on cubing ends with 44? Just if you do logically, you will get, sir. There is a number on cube. It is ending with 44. X cube is ending with 44. X has to be 4. Slowest number is 4 cube, 64. I want 44. Next is 14 cube. If you use a plus b whole cube, you will get 2744. So last two digits is 44. So what is the logic? X cube 50 plus x whole cube. Last two digits are same. X cube and 50 plus x cube. Last two digits are same only if x is an even number. X is 14. It is an even number. So 14 cube. Next it is 50 plus 14. 15 plus 14, 64 cube. But I require a 3-digit number. So in 14, these hundreds place can become 1, 2, 3 till 9. 114, 1, 214 and 7 whole cube. This is a 3-digit number. Hundreds place can become anywhere from 1 to 9 ending with 64 cube. 14 cube or 16 cube. So 9 numbers plus 9 numbers. 9 plus 9, 18 numbers. 18 numbers on cubing, I will end with 44. Sir, how you got this one? You think logically, sir. Lowest is 14. Next is 64. If I take x as 64, what is 64 plus 50? 114 cube. If I take it as x 114, 164. Again if I add 50, 214. Again if I add 50, 264. And so on. 914 and 964. So here 1 to 9, here 1 to 9. What is 9 plus 9? 18 numbers. I hope the logic is clear.